MS Ramaiah University of Applied Sciences.
Hi students, let us discuss the experiment on operational amplifier design and test the precision rectifier for full wave rectification. To construct and test the performance of a full wave precision rectifier using IC MU-A741. The figure shows the circuit diagram of an op-amp full wave rectifier and the output waveform. The output of the full wave rectifier is observed for both positive and negative half cycles. The result of op-amp full wave rectifier is noted in terms of volts, and on time, off time in terms of seconds is also noted.
Dear students, today I am going to explain the experiment of precision rectifiers. In that we have two types of precision rectifiers. One is full wave precision rectifiers and another is off wave precision rectifiers. So now I am going to explain the full wave precision rectifiers. To explain this experiment, we need these components. One is signal generator. So this is the signal generator. This is the main power button to switch on the signal generator, and this is the on and off switch to exhibit the waveforms to the circuit board, and this is the monitor to display the waveform, and this is the sine wave, square wave, ramp wave, pulse wave, harp wave, and noises that will be used to generate the signal to the input for the circuit. DC regulated dual power supply. This is the DC regulated dual power supply. So this is the main switch on button to switch on this particular system. So we have two main parts here. One is this part and another one is this part. So I'm going to explain what is this part. So this is the voltage tuner and this is the current set tuner. So in the voltage tuner we have two main categories. One is coarse tune and one is a fine tune. If you want to tune your voltage to maximum level in maximum numbers, that will be used by coarse tuner. If you want to tune the voltage that in the minimum level, that will be choose with a fine tuner terminal. So if you want to set your current, that will be based upon the application, so you can set by using this current set terminal. So in our circuit we will always keep this as a maximum current, and we have two main terminals. One is positive terminal and another is a negative terminal. So positive terminal is indicated by a red color and negative terminal that will be indicated by a black color. So this provides positive and negative voltage to the circuit, and the same operations what happens in this system that will be happen with this part also. And this is the ground connection. Normally we are used to this terminal in a very large applications. This is the display that will be used to display the values of voltage and current that will be generated to the system. Digital oscilloscope. This is the digital oscilloscope that will be used to measure the output. So in this device, this is the switch on button, so to turn on this system, and we have main two terminals. These are the one terminal and these are the another terminal. So we call this as a channel number 1 and the channel number 2 that will be used to see the output. Okay, these are all the tuners to adjust the amplitude and frequency of the signal. Circuit board. So this is the circuit board or breadboard. This is used to connect our entire circuit. Okay, this is the series connection till this large gap, and again this is a series connection. So this is a series connection in x-axis, and this is a series connection in y-axis till this division that will be counted to 5. Till that it is a series connection. After that this is one connection. 5 10 kilo ohm resistors. 10 kilo ohm resistors, 5 numbers I am using in this experiment. 2 MU-A741 operational amplifier ICs I am using in this experiment, and 2 diodes. I am using 2 diodes in this experiment. So to connecting the diodes, so see here, one is black and another is a silver color. So this silver color that will indicates the negative side, and this black color that will indicates the positive side of the diode. And connecting wires, these are all the connecting wires to connect the circuit. Patch cards. This is the patch cards that will be used to connect the input and output devices to the circuit. Now let us start the circuit connection of full wave precision rectifiers based upon the circuit diagram. Now I am taking two MU741 ICs. Okay, I placed into a circuit board. One IC I placed here, and another IC I am going to place in front of this, like this. Now I am taking the diode, see, negative end, and the negative end that will be connected to 10K, so that the positive end that will be connected to pin number 6, positive end of this that will be connected to 5, 6, this is pin number 6, to somewhere in the board first. This will be connected to somewhere in the board. After that I am taking 10 kilo ohm resistor. The 10 kilo ohm resistor that will be connected to this point to the pin number 2. This is 1, 2, this is pin number 2. I am connecting this into pin number 2. Now I am taking 10 kilo ohm resistor, and I will connect this 10 kilo ohm resistor to the pin number 2 to somewhere in the board. I will connect it like this, somewhere in the board. Later I will take the diode and I will connect the positive end of the diode to this connected resistors like this. This is in series. It will be connected to pin number 6. I need to connect. This is pin number 6. See here, it will be connected between the resistor and the pin number 6. Pin number 6. Now I am taking the 10 kilo ohm resistor to connect the input from the pin number 2. You see here, this is pin number 2. Pin number 2 to input I need to connect. So I connect first this resistor to somewhere in the circuit board, connected like this. After that I am taking another 10 kilo ohm resistor and I connect this diode point, to pin number 2 of the another 741 IC, MU741 IC. So this is pin number 2 of the other IC. I will connect it, the resistor 10 kilo ohm. Next I take another 10 kilo ohm resistor and I connect the pin number 2 to pin number 6. This is pin number 2 of the other diode, other MU741 IC, and I connected that into, shorted that into pin number 6 using 10 kilo ohm. Later I will take the connecting wires, the positive the wire that will be connected to DC regulated power supply to pin number 7 of the first one. 1, 2, 3, 4, 5, 6, 7 of the first one. This is 7th pin. I will connect it here. This is 7th pin. Next, negative of the terminal, I will made it into ground. Made it into ground. Another part of the positive terminal will be connected to the ground. This is the ground point connected to ground. The negative of the another terminal will be connected to the pin number 4. This is pin number 4. One, two, three, 4. So this is pin number 4 I connected here. Next, I am taking another positive end wire and made this with a short with another MU741 IC. So I take the pin number 7 of this, pin number 7 of this terminal I made to short with the another IC MU741 7th pin. Now both are connected with a positive. Next, I am taking another with a ground connection. So I made the pin number 4 to negative ground. This is negative ground I connected here. So plus VCC we given, minus VCC we given to the circuit. Okay, that is shorted. Now I am going to connect the input terminal by using the patch cards. I am taking one patch card. To connect the input, I connect the patch cards to the signal generator. The positive of the signal generator I am using as an input that will be connected to the terminal of the resistor. Already make it as a free. So now I am to connect with a input. The negative I made to ground, negative terminal. Made it into ground. This is the ground connection. I made it into ground. I want to see the input and output at the digital oscilloscope. I connect the one port terminal to input. Then I take another wire and I will connect this into a input terminal where I connected here. So this is the input point I am given to the circuit. I connected that point to there. Next, the negative of the output oscilloscope terminal that will be connected to ground. This connection is used to see the input at the digital oscilloscope. To see the output, connect the another channel number 2 to another terminal. The positive of the terminal will be given to pin number 6 of the second operational amplifier IC. So pin number 5 and pin number 6. This is pin number 6, and to connect this into and the negative I made it into ground. Taking another this thing, and I made already this as a ground. I connect directly to the ground. This is the circuit setup of our precision full wave rectifier. Now you switch on the signal generator. DC regulated dual power supply and the oscilloscope. here in the signal generator, so we need to give some setup. So we need to on this input to communicate for the signal. So switch on the channel 1, so because we are connected the wire to channel 1. Next we have 1 megahertz here, so that we need to set it to 1 kilohertz of frequency. So you click on this frequency button. This is a frequency button. So here you have frequency. In that frequency you type 1. Here we have kilohertz, so choose this one button, and 1 kilohertz of frequency will be set in the signal generator. So next you, in the DC dual power supply, you need to increase to some 12 volt. So you can find the output of full wave rectification, precision rectification at the digital oscilloscope monitor. So here you can see this is some five not 8 millivolt of output we are getting at the output oscilloscope. To measure the amplitude of this signal, so we are going here. So we are using one knob called multi-purpose knob. You click on the multi-purpose knob. So here you can find the type of an amplitude. So you click on this button. Now it will be shown off, amplitude and time. So we need to measure the amplitude, so that you turn this one like this, the color will be changed. So this is an amplitude measurement. You say it is okay. You press this one, it should okay. Now you rotate this, we can find this cursor. This cursor will comes down to the peak level. So this peak level will says that how much output voltage will be appeared at the monitor. So you find here delta V is equal to 1.04 volt. So 1.04 volt is the output we measured at the output terminal.
At MSR UAS, we spark your imagination unlike any other.